Welcome to Spaceverse, your portal to cosmic adventures. Imagine looking into a mirror that doesn't just reflect your face, but the dawn of time itself, not your reflection, but the birth of existence. A moment when the universe was still inhaling its very first breath. That's exactly what the James Webb Space Telescope was designed to do, to gaze so far into the past that it could witness the universe's earliest moments. But when Webb looked deeper than any instrument before it, it didn't see the fragile infancy of creation. It saw something that defied reason, a cosmic contradiction that left astronomers speechless and shook the very foundations of modern cosmology. For generations, scientists believed they had the universe's history neatly mapped. First came the Big Bang, the explosive birth of space and time. Then followed the long, dark silence before the first stars flickered into existence. Over billions of years, those stars clustered into galaxies, and only much later came the chemical complexity that could give rise to planets, atmospheres, and eventually life. The deeper we looked into space, and therefore further back in time, the simpler things were supposed to become. A universe of diffuse hydrogen clouds, scattered matter, and chaos without structure. But when Webb pointed its golden mirrors toward a seemingly empty, unremarkable patch of darkness, one of those voids we thought contained almost nothing, it captured something that shouldn't have been there at all. A galaxy, not a faint, primitive smear of early light, but a grand, fully developed structure, spiral arms gracefully curling, a glowing core bursting with energy, and a massive black hole anchoring it all. Not just a galaxy that existed, a galaxy that thrived, and that was only the beginning. One by one, more of these impossible galaxies appeared in Webb's data, each one older than logic should allow, each one structured, bright, and already rich in heavy elements. It was as though the cosmic clock had leapt forward billions of years in an instant. Every new image deepened the mystery and amplified one haunting question. What if our understanding of the universe's beginning is wrong? The first time Webb captured a galaxy over 13 billion light-years away, astronomers expected a fuzzy glow, barely distinguishable from static. Instead, they saw spirals, elegant, organized, mature, the kind of galactic beauty that should have taken eons to evolve. It wasn't a newborn galaxy still forming. It was ancient, complete, and impossibly sophisticated. To grasp how unbelievable this is, consider how galaxies are supposed to form. In the early universe, matter was spread thin, drifting aimlessly. Gravity, over hundreds of millions of years, slowly drew it together into dense clouds. Those clouds collapsed to form stars, which over vast periods gathered into galaxies. That slow, cosmic dance takes time, a lot of it. But Webb's observations told a different story. It had all happened incredibly fast, almost instantly. It was as if you planted a seed and, seconds later, stood in the shadow of a 2,000-year-old redwood tree. And this wasn't just a single fluke. Webb found galaxies all across the sky that were stable, mature, and chemically evolved. The telescope wasn't wrong. The universe's story, as we thought we knew it, was. Then the spectral data arrived, the light analysis that reveals the elements within these galaxies, and with it came another shock. These galaxies weren't made of the simple hydrogen and helium expected in the early universe. They contained oxygen, carbon, and even iron, elements that should only appear after generations of stars live and die. See, heavy elements don't exist at the beginning of time. They're born in the cores of massive stars and released when those stars explode as supernovae. That process, the birth, life, and death of multiple star generations, takes hundreds of millions, if not billions, of years. But Webb was detecting galaxies that were less than 400 million years old, already rich in these elements. That meant multiple rounds of star formation and destruction had somehow occurred almost immediately after the Big Bang. The early universe wasn't creeping awake, it was sprinting, burning, and exploding in hyperspeed creation. And the presence of those elements wasn't just a curiosity. They're the very ingredients needed for planets, water, and potentially life. To find them so early is like discovering a thriving coral reef around a volcano that erupted yesterday. The timelines weren't just compressed, they were shattered. Then came perhaps the most mind-bending revelation of all. In the heart of one of these early galaxies, Webb detected a supermassive black hole, over 1 billion times the mass of our Sun. Even in today's universe, that's huge. But to exist only a few 100 million years after the Big Bang? That's beyond reason. Black holes, as we understand them, start small, the remains of massive stars, and slowly grow by consuming matter and merging with others. Even under the most aggressive growth models, it's impossible for one to reach such monstrous size so soon. It was like meeting an adult human who claimed to have been born an hour ago. But the data was clear. The gravitational distortions, the emissions, the energy signatures, everything confirmed it. That black hole didn't grow into existence. It appeared ready-made. Astronomers were forced to reconsider everything. Some began exploring radical possibilities. Maybe these were primordial black holes, formed directly from dense regions of the early universe, skipping the star phase entirely. Others speculated that dark matter, that mysterious invisible substance, might have accelerated cosmic evolution. But these weren't small tweaks to our equations. That required rewriting the blueprint of reality itself. And then things became even stranger. When scientists analyzed the arrangement of Webb's galaxies using AI and mathematical models, they found an unsettling pattern. The galaxies weren't scattered randomly. Their distribution followed a ratio almost identical to the golden spiral, the same mathematical pattern found in seashells, hurricanes, and even DNA. This wasn't merely aesthetic coincidence. It was structural, a geometric order woven through billions of light years. The symmetry, spacing, and rotation hinted at a universal rhythm, as though the cosmos itself were following a hidden formula. Was this a new law of physics? Or something far more eerie, a kind of cosmic design, fingerprints etched into space-time itself? But Webb wasn't done rewriting reality. In one of the emptiest voids ever observed, where no stars or planets were supposed to exist, it detected faint chemical traces, not simple gases like methane, but complex organic molecules known as polycyclic aromatic hydrocarbons. These are the same compounds that form the foundations of amino acids, the seeds of life. And here's the twist. They weren't bound to planets or stars. They floated freely through space, intact after more than 13 billion years. That discovery changed everything. It suggested that the building blocks of life weren't born in special places like Earth. They were written into the cosmos from the very start. Life wasn't an accident. It was a fundamental feature of the universe itself. Then came an image that left even the harshest skeptics silent. Deep within a cluster of ancient galaxies, Webb captured a structure too symmetrical to be dismissed as coincidence. 6 galaxies arranged like petals around a central core, each evenly spaced and orbiting in perfect rhythm. Scientists called it the flower. At first, they tried to explain it through gravitational lensing or statistical chance, but every simulation failed. It wasn't chaos. It was choreography, a cosmic design too deliberate to ignore. But the strangest revelation wasn't about distant galaxies or monstrous black holes. It was about us. Some physicists noticed something unsettling. Webb's images seemed to change slightly over time. Tiny shifts in patterns, faint differences depending on when or how they were observed. It was as if the very act of looking, of observing, was affecting what was being seen. This echoed the quantum observer effect, where subatomic particles behave differently when measured. But what if that rule didn't just apply to the microscopic world? What if the entire universe is responsive to observation, aware of being watched? Could it be that by building Webb and turning it toward the deepest corners of existence, we didn't just uncover cosmic secrets? We triggered something, awakened something? The James Webb Space Telescope hasn't just expanded our view of space, it's rewritten our relationship with it. What it's showing us isn't only the story of galaxies, stars, or dust drifting through ancient light. It's showing us the nature of truth itself, vast, ancient, and deeply intertwined with consciousness. We didn't just see the unimaginable. We unlocked it, not through force, but through curiosity, by daring to look deeper than anyone before us. Galaxies too mature, chemistry too complex, patterns too perfect, signals too aware. Webb hasn't just revealed a mysterious universe, it has revealed a universe that might be aware of us. Maybe we didn't find the beginning of everything, maybe we found its memory, and maybe it remembered us. So the real question isn't, what did Webb see? It's, what saw Webb? If these revelations made your spine tingle, if the patterns feel too deliberate, the timing too uncanny, you're not alone. Subscribe to Spaceverse because we are not just witnessing the universe. We are witnessing its response. Turn on notifications because the next discovery might already be unfolding as we speak. And share this video with someone who still believes the cosmos is silent. Now tell us in the comments, what do you think the James Webb Space Telescope truly saw, or perhaps what it woke up?